In this video, we show how quantization can reduce latency in generative AI models and how to implement it step by step. Imagine waiting endlessly for your AI assistant to respond. High latency doesn't just frustrate users, it cripples real-time apps and spikes operational costs. Luckily, there's a fix. Why does latency matter? Faster responses improve user experience, cut infrastructure costs, and let you scale efficiently, maximizing performance and ROI. So, where does latency come from? It mainly comes down to three things: model size, hardware capability, and inference architecture. Optimize these, and you're on the fast track to better performance. First, convert your existing TensorFlow model into a TensorFlow Lite.tf Lite file using the TensorFlow Lite converter. Python code snippet demonstrates converting a Keras model into a lightweight .tf Lite format, optimized for deployment. Before deploying, always validate accuracy. Quantization may reduce it slightly. Ensure it stays within acceptable limits for your application. Quantization is a trade-off: faster speed with slight accuracy loss. The key is finding the right balance for your use case. But quantization is just one piece. Combine it with caching and batching to boost performance even further. Boom! Quantization cuts latency by shrinking model size, enabling faster, more efficient AI apps. Now, go optimize.